learning goal today, over here, is I can change rates. We worked with rates yesterday, but today we're going to change them to different units of measure. So sometimes they're given to us, maybe it's given to us as miles per hour. But instead, they want us to change it to like feet per second. You want to know how does that speed change to a different unit of measure. So that's what we're going to be doing today. You will be doing things like this in science class. Have you yet had to do any converting in science class this year? I know it's coming if you haven't had to do it yet. So pay really close attention because I believe Mrs. Clayville has you do it the same way that I will have you doing it using conversion factors, okay? So we're going to change our rates to different units of measures by multiplying by a conversion factor. Sometimes we have a really hard time deciding when we are trying to convert something, we have a really hard time deciding whether we should multiply or we should divide. Or we just do one or the other and we don't really care whether we're right or not, we just get an answer. We don't worry about if it's reasonable or not. So when we multiply, we're always going to multiply by a conversion factor, then we don't have to make that decision. So let's just talk about, there's a ton of conversion factors out there, a ton of them. So let's just go through a few here. In 1 foot, there's how many inches? Cody? 12 inches. Okay, so, and it's going to be important that we can write these down first when we are working through the problems to help us be able to set them up. 1 hour is how many minutes? Devontae?
60.
60 minutes. 1 year has how many weeks? 1 year has how many weeks? Cody, are you really the only one who knows the answer to this? Come on, hands up if you know the answer to this. 1 year has how many weeks? Okay, Cody, help all those other ones out.
48.
Oh, you guys that thought you knew it, are you going to agree with him, Noah?
No.
Oh, how many are there?
36.
Those of you, the others that thought you knew, are you going to agree with either of these guys, or are you? 36. We really don't know how many weeks are in a year.
I do.
This is so scary.
Can I tell them I know?
Go ahead, Cody. Try again.
There is 1 year equals 12 months, which in every month there is 4 weeks times 4 weeks times 12 months, you get 48 weeks.
So you're going to stick with your answer, 48 weeks.
Yes.
I'm sticking to it.
Yes.
Okay, well then, if there's 4 weeks, how many days are in a week?
7.
7 days in a week. Okay, and you said there's 4 weeks in a month. So that means every month has 28 days. Because 4 times 7 is 28. Does every month have exactly 28 days then?
No.
Oh, well, who's messed that up? In fact, in the month of November, there are 30 days. So I guess now there's 48 weeks and 2 days. What's the only month that has 28 days in it? February, and that's when it's not a leap year. But so all the other 11 months have more than 28 days. So do you think we can stick with your answer, Cody? Let's try again. 56. Well, that would be, that's another 8 weeks, and that would be 8 times 7, that would be another 56 days. That would be extra days every month past 28. That seems a little high. Oh my goodness, I can't believe I have to stand here and get this figured out with you. Noah?
I believe that there are 60 weeks.
60 weeks. Now it's up to 60. Oh my goodness. Okay. Mr. Conlon, could you help us out, please?
Yes, I can. How many days are in a year?
365.
Okay. And how many days are in a week?
7.
So if there's 7 days in a week and 365 days in a year, just divide 365 by 7.
Mr. Conlon to the rescue. Oh, and then if you have a calculator, it works so much faster too. Cody, for the final answer, this is your final chance, buddy. How many are there?
52.14285714.
Okay, well now, Mr. Conlon, are you saying that there's a partial week in the year? Since
No.
there's 365 days?
That is what leap years are for.
That's what leap years are for. It's exactly 52 weeks. Okay, get that one planted. After all that, that better stick. When somebody says to you, for $100, how many weeks are in a year? You're gonna be able to 52! Oh.
Nope.
Okay, I'm glad we did that one. 1 mile is how many feet? Or Julia?
5,000. I think it's 6. I just thought it's 5,000.
It's 5,000 something, I'll give you that. Devontae?
5,105.
Cody?
5,872.
Oh. Okay, I'm just gonna give it away, because this is gonna take too long for us to figure it out. Okay, write that in.
I was so close.
Tell you. Oh, gosh, we got a lot of conversion factors to learn, I guess. Okay, well that's just some of them. Those are some of them that we might use today, and then there might be some others that we're going to use today. And when we have a conversion factor, here's the deal. In a way, they're like a unit rate, but when we use our conversion factor, sometimes instead of it being per 1 unit, we're going to put the 1 unit upstairs sometimes. We're going to put the 1 unit wherever we need it, so that it will help us be able to do the conversion. But there's always going to be per 1 of something, okay? And then we'll just decide whether that's going to go upstairs or downstairs. Cody?
If we use mile, when we do like the conversion factors for miles, can we also use yards?
You can. So you know the conversion factor for how many yards are in a mile?
I think I do.
Okay, how much is it?
It's like 1,720.
Okay, and how did you get that?
I
Because you're close, but
divided how many feet in a yard by
how many feet are in a yard, by the way?
3.
3 feet for 1 yard, there's another conversion factor. And then Cody's trying to say there's 1,720 yards per 1 mile. But if there's 3 feet in a, we'd have to take, in a yard, we'd have to take 5,280 and divide by 3, and that would be 1,760, not 20. Okay. So there's another conversion factor. So yeah, you can use it with the yards. You get to use, you make your conversion factors, but they can't be crazy ones like 1 year equals 60 weeks. You know, it's gotta be true, okay? So, a cyclist travels 56 miles in 4 hours. Convert the cyclist's speed to feet per second. Would you circle that right there? In the end, we want feet per second. So, first thing we have to do is we're going to set up our ratio in something that makes sense. So 56 miles in 4 hours. Does it make more sense to put the 56 miles upstairs and the 4 hours downstairs? Or do we want the 4 hours upstairs and the 56 miles downstairs? Do we want miles per hour or hours per mile? Miles per hour. So let's do this right here in this little white space. I didn't leave us a whole lot of space. 56 miles over 4 hours. There's our ratio. It's not a unit rate right now, but it doesn't matter that it's not a unit rate. It can be, but it doesn't have to be. We need to convert that to feet per second. So what we're going to do is we're going to say this has to become feet, and this has to become seconds. So before we divide it out, we need feet upstairs and we need seconds downstairs. Okay, so we're going to write down the conversion factors. You only have 5 problems of homework to do, and I expect you to do this much work, okay, what we're going to do here. So we set up our ratio. We decided what do the things need to change to. Sometimes only one of them needs to change, by the way, not both of them. And then we're going to say, well, what conversion factors do I need? Well, I got to go from hours to seconds, so I'm going to start with 1 hour equals how many minutes? 60. That one we know. Okay. But then I still need it to be seconds, so now I'm going to go, I need to go with 1 minute equals how many seconds? 60 seconds. So I need, now I have my seconds, so I can stop with the time conversion factors. And now I'm going to move to I need to go from miles to feet. So 1 mile we said equals 5,280 feet. And we needed it to be feet, so we get to stop with conversion factors for that. Now, that's just writing them out, okay? So now what we're going to do is we're going to show our setup that's going to help us get there. So we're going to write 56 miles over 4 hours. and we're gonna multiply by a conversion factor. We can either start with the time or we can start with the distance. Which one do you wanna start with?
Distance, because you have a greater number.
Okay, let's do distance. So if we're gonna get rid of the miles and get them to be feet, we need the miles to cancel out. Right now, all we're worried about are the labels canceling away. So if miles are upstairs, to get them to cancel, in the conversion factor, in the multiplication, where do the miles need to be? Downstairs. So we're gonna put our 1 mile downstairs, which means that the mile is downstairs, the other part of the conversion factor has to go upstairs. And right now, we don't even care about multiplying or dividing or anything. All we're doing is getting it so that we only have 1 label upstairs and 1 label downstairs in the end. And that label upstairs better be feet, and that label downstairs better be seconds. So the miles are going to cancel out, just the miles, just the label. So if we stopped right now and said, I'm ready to do the math, when we're done, we'd have feet per hours. Is that what we want? Nope, so we got to do another conversion factor. Now we want the hours to cancel away, because we've already got our distance changed to feet, kind of. So now we're going to use the conversion factor that'll go from hours to minutes. So do we want the 1 hour upstairs or downstairs in this one? We need it to be upstairs because it's downstairs right now. So our hour goes up, our 60 minutes goes down. I didn't allow myself enough room here, I'm writing too big. Okay, and does anything cancel away now?
Yes.
What cancels?
The hours.
The hours cancel, so this cancels with that. If I stopped right now and did my multiplying and my dividing, I would have feet upstairs and minutes downstairs. Is that what I want?
Nope.
No, and so now we're gonna have to use our other conversion factor. We haven't used our 3 yet, we have this one left. So do we want our 1 minute upstairs or downstairs? The minutes are down right now, so we need it up. 1 minute over 60 seconds. If you guys have room to write, I've run out of room. Okay, what cancels away?
Minutes.
The minutes cancel away. Okay, if I stop now, I look upstairs and I see my only label left is feet. If I look downstairs, I see my label left downstairs is seconds. If I move on now, I could be, when I get done doing my multiplying and dividing, I have feet per second, wouldn't it? Okay, so now we're gonna do, that's what we're gonna do. We're gonna multiply 56 times 5,280 times 1 times 1, and we have 4 times 1 times 60 times 60 downstairs. That's how we multiply fractions. We multiply the numerators, we multiply the denominators. There's other ways too, but I think in this scenario we're going to do it this way. This would be one of those times you don't want to be without a calculator. You have to do longhand multiplication and division. When you're done, see if you need to challenge my numerator product and my denominator product, or do we agree? Okay, and remember these are feet, that's the only label left upstairs. These are seconds, that's the only label left downstairs. And now this is just like our problems yesterday where we changed them to a unit rate. And we're going to have the unit rate in the measure that they wanted us to have it in. So the next thing we would do is what? 295,680 divided by 14,400. 400. We would know how many feet per second is really the same as 56 miles per 4 hours. Who's got it for me? Noah?
20.53 repeating feet per second.
Okay, so did it say anything in here? Let's round to the nearest 10th. So what would this be rounded to the nearest 10th? It was 5/3 repeating? Okay, so is that 3 big enough to change it to 6/10? No, so we're going to say approximately, we have to change our equal sign to approximately to show we rounded, 20 and 5/10 feet per second. There's a couple of different ways you could write that. You could do FPS, or you could do it like that. Okay. Now, there is something that we could have done a little bit differently in this one. And I'm just going to point it out and draw it to your attention. In the beginning, when we had 56 miles over 4 hours, we could have simplified that fraction. Does 4 go into 56? How many times? Anybody know? More than that. That'd be 36. How many times is
14.
14 times. We could have changed that to 14 miles per 1 hour. We could have made that into a unit rate to start with, and then we would have been working with smaller numbers. So that's another thing you can do. If you can simplify the fraction to begin with, change it to a unit rate that has nice numbers in it, then you can work with it that way. So we would start with that number here instead. We wouldn't have quite as big a numbers to work with. So anybody have questions? Okay, let's try one more. We have nutritionists that they recommend that teenagers, that would be you guys, not me, consume 1,300 milligrams of calcium per day. You think you guys are doing that? 1,300 milligrams. So when you look at, when you drink that carton of milk at lunch today, see how many milligrams of calcium are in it, okay? Convert this to grams per year. Okay, so for right now, you know what, let's just cross this out and give ourselves more room. Okay, for right now, we have 1,000 milligrams per day. We got to change it to grams per year. So it looks like the milligrams need to go upstairs. And the per day, that'd be 1 day downstairs. So we need the upstairs label to change to what?
Grams.
Grams. Grams per year. So grams, that one has to change to grams, which is G. And this one has to change to
Years.
a year. Okay, or years. Okay. So let's figure out some conversion factors that will help us do that. Okay? So we need milligrams to go to grams. Is there a conversion factor that goes directly from milligrams to grams?
No.
Anybody happen to know it? How many, which one's bigger, milligrams or grams?
Grams.
Grams are. Anybody happen to know how many milligrams are in a gram? Or in other words, so let's do our need here. Need. We have 1 gram, because that's the bigger, equals how many milligrams? Devante?
1,000.
1,000. That's right. 1,000 milligrams. Okay? So we need that one. And that already takes care of, so we got grams changed to, or milligrams to be changed right to grams. We don't need any more conversion factors for that. Now we need to deal with the fact that we got days and years. So can we go directly from day to years?
Yes.
Yeah, we know how many days are in a year. How many days are in a year?
365.
365 days equals 1 year. Okay, so we only need 2 conversion factors this time, don't we? So what do? Start with our ratio that we have, And you need to put your labels in these because that helps you be able to know how to set up your conversion factors, in what order. So times, let's just do them the way we have them here. Let's do the grams and milligrams first. Should we put the 1 gram over 1,000 milligrams or the 1,000 milligrams over 1 gram? Which way should we do it? We need the milligrams to go away.
We need it to be on the bottom.
So we need the milligrams to be on the bottom, don't we? So the 1,000 milligrams needs to be on the bottom, which then puts the 1 gram upstairs. Because now, if we can't do this, we can't do some canceling, we don't have a good setup. And we gotta go back and flip it. And then we're going to multiply by our other conversion factor. We got days and years. Do we want
Days should be on top.
days should be on top because they're on the bottom over here. So we need 365 days over 1 year. Now our day label can cancel away. We have grams upstairs, we have years downstairs. Is that what they want? Grams per year. We're ready to multiply. Okay. Hey, by the way, does multiplying by 1 do anything? What is it? Just keeps it the same? So we could just kind of ignore those guys. 1,300 times 365 over 1,000. So I get it should be 4, not 475. It should be 474,000. Is that right? Is it 474,000 class?
Yes.
500 grams upstairs over 1,000 years downstairs. Hey, what's the shortcut for dividing by 1,000?
You cancel out the zeros.
Cancel out the zeros. Well, we don't have any zeros to cancel out upstairs. If we had some zeros upstairs to cancel, enough of them, we have enough. We would need 3 upstairs. We only have 2. So we could cancel out a couple of them anyway then, right? We could do that. We could say, you know what, these guys can cancel. Now we got 4,745 over 10 divided by 10. That's a little bit, less to deal with. So 4,745 divided by 10. I'm trying to get you not to take out your calculator for this. Yeah. Take those fingers off the calculator. When you divide it by 10, it's the same as
4,000.
moving the decimal point
1 place to the left.
1 place to the left. That's right. So this would be
4,704 or 474.
don't say and. 474 and 5/10, and these are what? Grams per
Year.
year. Yeah, grams per year. So if you need 1,300 milligrams per day, that calculates out to 474.5 grams every year. Okay, so that's our final answer here. Okay, looks like you're done.